Hi everyone, myself Vamsi Krishna. In this session, we are going to discuss in detail about what is Elasticsearch and how does Elasticsearch works and what are the components of the backend, and then what is ELK stack and what and all use cases will be supported by Elasticsearch. This is like mostly like a introduction kind of thing. Once everyone understands what is Elasticsearch, how does Elasticsearch work, what are the use cases, in the next session I'm going to do Elasticsearch installation on different operating systems. We'll get started with understanding what is Elasticsearch. If you can see the definition, Elasticsearch you can think of like a server which will process JSON request and give you back JSON data. Let me show you a sample JSON. This is kind of JSON. JSON is nothing but JavaScript object notation which has keys and values. Left side is the model definition and right side is the equivalent JSON. Here this JSON has employee ID, employee name, employee salary. This JSON is nothing but key value pairs, basically comma separated key value pairs, which will be having like this. Now, if you read this, Elasticsearch is a distributed open source search and analytics engine built on Apache Lucene and developed in Java. Meaning, if you want to work with Elasticsearch, you need to install Java and then you can use Elasticsearch. And Elasticsearch is an open source search and analytics engine. And next thing, Elasticsearch will allow you to store, search, and analyze huge volumes of data quickly and in real time and give back answers in milliseconds. Basically, Elasticsearch has a fast search response because instead of searching the text directly, it will search an index. It uses a structure based upon the documents instead of tables and schemas. And we have the equivalent REST APIs also for storing and searching the data, which I will be showing in detail in the next session. Finally, you can think of Elasticsearch as a server that will process JSON request and give you back JSON data. How does Elasticsearch work? What are the components involved in Elasticsearch? Whoever is working with Elasticsearch, they need to know couple of terminologies involved in this Elasticsearch, how the data is organized, and what are various backend components. Let us see one by one. The first thing which will be there in Elasticsearch is document. Documents are the basic unit of information that can be indexed in Elasticsearch expressed in JSON, which is global internet data exchange format. Basically, whatever the JSON you have, that JSON will be stored as a document, and you can compare document like a row in your normal relational database structure. A document can be more than just text. It can be any structured data encoded in JSON. If you see, this is a document. Any data which is encoded in JSON is called document in Elasticsearch. The data can be numbers, strings, and dates. It can be anything. Each document will have a unique ID and a given data type, which will describe what kind of entity the document is it. For suppose, in this example, I have employee. If you have any logs of any Apache web server, you can represent that also as a document. Okay. Finally, to summarize, you can think document like a structured data encoded in JSON. The next concept is indices. An index is a collection of documents that have similar characteristics. For suppose, if I am storing this JSON, right? This is employee JSON. Assume this is employee JSON. Let's say if I have one more record, this also is employee 200. This is Krishna. This is 20,000. right? This is also one document. Index is nothing but a collection of that documents which will have similar characteristics. In this case, employee ID, employee name, employee salary. In the second document also we have employee ID, employee name, employee salary, which has similar characteristics. Then we can call this as an index, which is nothing but a collection of documents that have similar characteristics. Index is the highest level entity that you can query against an Elasticsearch. You can think of index as database in relational database schema. In normal MySQL, Oracle, you have schema concept, right? Database schema. In Elasticsearch, index is similar to database schema. Any document in index are typically logically related. In case of e-commerce website, for example, if you have any customers, one for product, one for order, and so on, those are all different indexes. Okay, an index is identified by a name that is used to refer to the index while performing indexing, search operation, update operation, and delete operation against the documents. This index will come into picture whenever you are trying to update a document, whenever you are trying to delete a document, whenever you are trying to search a document, or whenever you are trying to index a document. Next, we have inverted index. An index in Elasticsearch is actually nothing but inverted index, which is the mechanism by which all the search engines work. This index is nothing but a data structure which will store the mapping from the content, like whatever the data you have. For suppose this is one data: the bright blue butterfly hangs on the breeze under blue sky in bright sunlight, one need no search around. Like this is one text document, right? It won't store this as it is. Instead, it will convert it into single search terms, basically each word, and then it will map the search term to the documents. For suppose if you see document 1, the blue word is present in document 1 and 2, bright term is present in 1 and 2, term or word you can call it same, right? The first one is ID1, ID2, ID3, something like this, and internally this is nothing but hash map like data structure which will have keys and values. This inverted index does not store the strings directly. If you see this is a string, it won't store the string as it is. Instead, it will split each document into individual search terms, which is nothing but word, and then maps each search term to the document. If you see the image, the term best occurs in both document 1 and document 2, and it is present here, right? And why do it needs this particular data structure is whenever Elasticsearch is performing the find operation, right? Whenever it is trying to search something, it will best match the full text search from a very large data set also. That is the reason Elasticsearch will be very fast. These are logical components, right? One is document, another one is indices, another one is inverted index. These are logical components which you cannot see physically, right? There are backend components which we can see physically in the configuration file. The first one is cluster. An Elasticsearch cluster is nothing but group of one or more node instances that are connected together. Let's say if you want to build a big search engine, right? Single machine is not enough. In that case, we need to create a cluster. Same concept applies in Elasticsearch as well. An Elasticsearch cluster is a group of one or more node instances that are connected together. The power of Elasticsearch cluster lies in distribution of tasks, searching, indexing across all the nodes in the cluster. Second thing, node. What is a node in Elasticsearch? Node is nothing but a single server that is part of the cluster. Node stores data and participates in the cluster indexing and search capabilities. An Elasticsearch node can be configured in different ways. Whatever the cluster we have, the cluster can have 3-node cluster, 5-node cluster. A node is nothing but a single server which will be part of cluster, and these nodes participates in the indexing and search capabilities. Master node. For each and every cluster, there will be a master node and there will be data nodes, right? The master node is nothing but which will control the Elasticsearch cluster and is responsible for operations like creating and deleting an index, adding and removing the nodes. Data node. Data node stores the data and executes data related operations such as search and aggregation. Data node will not add and remove nodes. Okay, data node just participates in storing the data and execute all the data related operations such as search and aggregation. And client node. Client node is nothing but which will just forward the cluster request to the master node and data related request to data node. This is nothing but the client node. Next, final one, shards. Elasticsearch provides the ability to subdivide your index into multiple pieces called shards. Each shard is in itself a fully functional and independent index that can be hosted on any node within a cluster. Why do we need this is, if you distribute your indexes, if you distribute your documents in an index across multiple shards, so that your data will be distributed across multiple nodes, and this will ensure the redundancy, which will protect against hardware failures, and the query capacity also will be increased. This is just for redundancy purpose, so that your data will be protected against hardware failures as well. And replicas. Elasticsearch will allow you to make one or more copies of your index shards, which are called replica shards, so that if you set up these replicas, you can provide redundant copies of your data to protect against hardware failure and increase capacity to serve read requests like searching and retrieving a data. If you have any shard, if you have any replica shard, instead of putting the load on the main server, you can perform the request like searching and retrieving a document easily. These are the terminologies which are present in Elasticsearch. One is cluster, another one is node, another one is master node, another one is data node, and the final one is client node, shards and replicas. The general terminology, Elasticsearch. Okay, the Elastic Stack is the terminology which everyone is calling nowadays. Elasticsearch is the central component of the Elasticsearch, which will contain Elasticsearch, Logstand and Kibana. And Elasticsearch is the central component of this stack. Whenever somebody wants to visualize their data, they are going to use Kibana, which is nothing but a data visualization and management tool for Elasticsearch. And using Kibana, you can create real-time histograms, line graphs, pie charts and maps. And Kibana will let you to visualize your Elasticsearch data and navigate the Elastic Stack. And depending upon your data, you can select the right chart, either histogram or line graphs or pie charts or maps, and you can create your visualization thing. For example, if you want to analyze your logs, right, you can use Kibana. It will allow you to analyze your logs, and it will allow you to answer questions from where the requests are coming to website and what are your distribution URLs and so on. If you are not building your own applications on top of Elasticsearch, Kibana is a great way to search and visualize your index. If you don't want to use Kibana, you need to use Grafana, and you need to add Elasticsearch as a data source for Grafana, and you can visualize it there as well. Next, we have Logstash. Logstash is used to aggregate and process data and send it to Elasticsearch. For suppose, if you have any data in CSV file, comma separated values file, or if you have any data in database, you can use Logstand and you can aggregate the data and you can process the data and send it to Elasticsearch. Logstash is also an open source server-side data processing pipeline that will ingest data from multiple of sources simultaneously, and you can transform the data also, like you can drop couple of fields, you can add extra fields, and you can collect, and then finally you can send it to Elasticsearch. And Beats is nothing but collection of lightweight single purpose data shipping agents which are used to send data from hundreds or thousands of machines and systems to Logstash or Elasticsearch. For suppose if you have different servers, you can simply put beads there. Beads will gather the data on those servers and it will send the data to Elasticsearch. For example, we have something called file beat, which can sit on your server, monitor your log files as they come in. They will parse them and they will import into Elasticsearch so that you can use Kibana to visualize it. Finally, these are the terminologies involved in Elasticsearch. What is Elasticsearch used for? Elasticsearch has lot of primary use cases. One is you can use it for application search, like accessing the data, retrieving the data, reporting of the data. And you can use it for website search also, where website has lot of content. You can use Elasticsearch, which is a powerful for again searching. And you can use it for enterprise search as well. For suppose if you have any applications like e-commerce, where you want to find certain products, or where you want to blog something, or where people want to search something, any form of search, right? You can use Elasticsearch in enterprise for e-commerce applications as well. And you can use it in logging and log analytics as well. If you have any logs, if you want to ingest the logs, and if you want to analyze the log data in real time, you can use Elasticsearch in those cases as well. And you can use Elasticsearch for infrastructure monitoring, infrastructure metrics, and container monitoring as well. For suppose if you have any metrics like CPU, memory, disk, these kind of metrics, you can still use ELK stack to analyze various metrics. And you can use it for security analytics as well. For suppose if you have any applications where you need to see the system security, and you can use ELK for accessing the logs, and in the logs seeing the system security related things in real time. And finally, you can use it for business analytics as well. When your application is running live, and if you want to see how good your market is going with your products, all these things, you can use this Elasticsearch, and you can use this as a business analytics tool, so that you can analyze the data using Kibana, using different graphs, and then you can help in better visualization and analytics on your data, so that it will be helpful for business. Thanks everyone for watching this video.